Hello, everyone. That's a Service Mesh with Istio series. We have here a GitHub page that you can follow from Rahul Ray, our speaker, and you have all the demos that you can clone this repo. You also have the Katacoda course. You can just click. We are going through all the scenarios. You can also get the Docker image used by the demos on the DockerHub, Fast Track Istio.
We are here with Rahul Rai again, Jorge Arteiro, and me, Fernando Rolnik. Last video we saw how to deploy an application on a service mesh Istio, and now in this video we are going to see some Istio patterns in action. So Rahul.
So if you have been following these exercise videos with us, thanks for being with us so far. In this video, we are going to talk about exercise number 4, where we'll see some of the Istio traffic management patterns in action. More specifically, we'll cover how with Istio you can implement patterns like versioning, fault injection, and how you can deploy Canary releases of your services. Let's switch over to the presentation. So this is my favorite diagram with which I generally explain traffic management policies to people who are interested in learning about Istio. This diagram captures all the networking APIs that are available in Istio. So let's understand what is going on here. So for instance, a client wants to talk to, let's say, service A, and it's available on hostname foo.com. So let's first discuss how a request would logically flow into the system, what all networking APIs it will meet on its way, and how it will ultimately reach service A. So from starting from the very left, we have the client. The request would first meet the API, the gateway API. Here you can see that the gateway API is configured to allow only the hostname foo.com on port 80. Since the request fulfills these criteria, it would move on. Next, a virtual service that is bound to this gateway will check which subset, or you can call it a version. So which version of service A this request is destined to. So say, for instance, you have two instances, two versions of service A running at the same time, version 1 and 2. It will try to identify which particular version the API request should be routed to. Say, for example, it is V1, then it moves the request along to the next API, which is the destination rule. The destination rule implements certain patterns in itself, which we'll learn about later. But for now, let's say the destination rule is the mapping between your virtual service and the actual service instance running in your cluster. So here, the destination rule specifies that version 1 of the service is mapped to service A that you can see in the on the left-hand side in the blue box. And it will also have specifications for where the V2 of the service is. Since the request is destined for V1 of the service, it passed the request along to the first and the version 1 of the service that the request was originally intended for. Now note that all of these API components, they are not physical entities, they are just logical constructs, because in Istio you have only two components running. One is the Istio daemon that that enforces policies on the sidecars that we discussed, which is an envoy instance sitting right next to your service, intercepting all the traffic. All these policies actually run on the sidecar, and the request ultimately has two components to hit. So if you look at the actual path, which is denoted here with a green arrow, it will first hit the gateway, which is the load balancer, and then it will straight away reach the destination envoy proxy. and ultimately the service. So those are the only hops of the request that happen. Within Envoy, all these policies execute in order. Also note that if a service within the mesh wants to talk to another service, it doesn't need to go reach the other service via the gateway. So gateway is an optional component. It just needs to here, if let's say the service X wants to talk to service A, then service X would just need to use the virtual service API to ultimately land at service A. So those are the APIs, high-level overview of the APIs that are available in Istio. Let's talk about each of these individual components in a nutshell. So the first API, we have already discussed about the gateway. We saw it in action in the previous demo. Let's now talk about the virtual service. So virtual service role in Istio is to route traffic to destination, like I just discussed in the previous diagram. You can have multiple conditions which the request needs to meet in order to reach a particular destination. And you specify all those conditions in sequence, and the conditions are odd, as in even if one of the conditions is satisfied, the rule set in itself is satisfied and the request moves along. Virtual service is an optional component, so it doesn't matter whether you specify a virtual service or not. You can, once services are on the mesh, you can use their name within the cluster to reach those services. You don't have to route each and every request via the virtual service. Another component that we haven't discussed previously, but is an essential part of the networking API, is the destination rule. As we discussed, that destination rule forms a mapping between the API, the version number, and the actual service name. And this comes into effect once virtual service has determined which target the service needs to reach. So for example, like in the previous example, previous diagram, we saw that there are two versions of service A running. The virtual service would determine which version of the service, which service the request should be routed to, which would be service A. But then which version of the service A should the request be routed to is determined by the destination rule. In addition to that destination rule, also this API also supports having certain configurations that you can enable on them, which will enable features like load balancing and TLS, which we'll again see later in action. So with all of these APIs that are available in Istio, you can implement various patterns. Each of these APIs on their own don't have much of a role to play. You won't be able to realize something very significant with them individually. But once you combine many of these APIs together, then there are many patterns that you can realize. So some of the patterns which we'll see next in our demo would fall into one of these categories. So the first pattern that we'll discuss is Canary deployments. So what Canary deployments mean is that you route a portion of your traffic to one of the versions of your services. So for example, if you have an existing service, now you have added some features into this service, but you don't want all the users to be able to reach this service, only a select set of your customers to reach, let's say, the new version of the service. Then you can do this sort of split by routing a part of by applying rule on the destination rule and then enable how traffic reaches one of the available versions of the service. You can split the traffic by percentage as well. So for example, if you just want to route 10% of the request to a version, 90% to another one, you can do that. You can also use request attributes. For example, presence of a new header in a request can be used to route traffic to a particular version. Next pattern that you can realize is fault injection. So what exactly fault injection is that you can spoof a particular service to return false or for a certain request. So let's talk about why this is useful. So for example, you have an application which consists of a number of services that are dependent on each other. You bring out a new version of the service, but you want to test how this service would behave if some or more of the dependent services are not available or are returning false. So instead of instrumenting other services to return false on a certain condition, what you can do is in Istio, you can spoof for certain spoof for some time that all the services that your new service is talking to would return false for when a certain criteria is satisfied. So for example, let's say if service A is talking to service B, you can spoof that service B will return false for 90% of the time and only return success for 10% of the time. So in a sense, you can test the dependency between two services by injecting false into one of the services. You again use the virtual service fault attribute for programming this.
Rahul, there was a question about that, and maybe a comment. There's a lot of people doing CI/CD and creating using kind or K3S, K3D clusters. They create a cluster and they run those kind of tests. I think it's some Istio now become very easy to test, to run like inside your pipeline. Have you had an experience with that?
Yes. So as we saw that Istio is just a binary that you need to install on your cluster. So when I develop my services on my system, I generally use kind and install Istio on it, just like we install Istio on the on a Kubernetes cluster. Is the exact same bits. I generally remove some of the non-essential services from it. For example, observability bits and a few others which are not essential for debugging your applications on your local system. But it's very well supported for local development as well.
That's great. That's great. It's good. It's a good match to kind in K3S, K3D clusters, and can like in seconds create a new cluster, run your tests, and do all these monkeying crazy things and fail testing, and then okay, that's great. Thank you.
So just to add to that, you can run it as well. The same setup that you have on your local system on Kubernetes as well, wherein you can run kind on your CI/CD in your CI/CD pipelines and test the reliability of your services on your CI/CD setup. There are some features that are available on AKS for testing purposes as well, wherein you can set up a temporary namespace in your cluster where your service can execute and essentially use that instance to test how your service would behave once it goes live. That's also quite interesting. But Istio's fault tolerance is quite useful for testing resiliency of services. So that brings me to my last pattern that I want to discuss here. First, as in for part one of traffic management patterns that we're talking. So versioning. As we all know, versioning is a very common thing that we all must have used sometime or the other in our careers. This just means that you have two versions of your API running. And you can route requests to either of the two versions of the APIs based on request headers or cookies or any other request attributes. Since Istio can look at the whole network packet, so you can apply some very high level OSI layer 4 to 7 rules on network packet. So you can use any of the layer 4 to 7 attributes and configure versioning based on that. It is programmed using the subset attribute. So that brings us to the exercise. So I will quickly switch over to my terminal. And if you
just one question on that, like, I think for me it's very important, like, I don't have to inspect the traffic to do the routing. I think that's what when you say layer 4, like a header, I mean, I don't have to really inspect all the the traffic on the HTTP to be able to do routing. And I think that's become very handy, for these kind of scenarios when I have multiple versions. And
yes, exactly. Totally agree with that.
Yeah.
So let's start with the easiest bit, which is versioning. So what we are going to do here is that the movies API that we deployed earlier, as we said, that it has 2 versions of the API that you can run at the same time, v1 and v2. So what I'm going to do here is deploy this spec. So let's first study this spec before actually deploying it. So you can see here that the first part of the spec is the namespace, which has this attribute of Istio injection enabled, which means that any deployments that go in it would have a sidecar accompanying it. If you look at the deployment, then I am deploying the version 1 of the movies API, and the label that I've used that I will later use in my destination rule is the app and version. So if I want to select this particular these bunch of pods that get created, although I would provision only 1 replica now, so if I want to select this pod, I can use these labels to select it. There's nothing much fancy here, but in a similar way, I have deployed version 2 of the movie. So the same container with a different tag. So nothing much fancy here. Again, to select this pod, specified labels here. So the name of the app is still the same, version number is different. Finally, I have exposed these pods with a single service. So here I have set the selector for the app. So since both the pods have the same app label, so the traffic, once I deploy it, all the traffic would be routed to one of the 2 versions because the service maps to both the versions of the pod right now. But till now, Istio is not yet in the picture. These are just Kubernetes specifications. So another specification that we are going to deploy here is the gateway virtual service, gateway and the virtual service. So if we look at the gateway spec, it doesn't have anything fancy here. All it does is it listens to port 80. And if we look at the next spec, which is of the virtual service, it binds itself to the gateway. And what this does is that it checks a specific header called version in the request. So if the version, if the header version matches the value 2, it would route the request to the subset v2. In all other cases, if any other version is specified or if no version is specified, then by default, the request would be passed to version 1 of the service. But what does exactly subset v1 and v2 mean is specified by the destination rule. So here you can see that there is a declaration for the destination rule. So here it specifies 2 subsets, which is v1 and v2. Here you can see that the same label that we used to discover our pods, which is the version label. We have specified the version over here. So these would be used to later target one of the pods that we deploy. So we'll use the same trick that we used before. Since we have two specs to deploy, either you can deploy them one by one or in a single statement. The best way to do it would be with a customization file. So I will jump here, copy. Okay, so I haven't changed to the versioning project. So it creates the services and the deployments. A cool trick that I learned recently was that Kubernetes has added a UI to discover your workloads. So you don't have to keep running the commands all the time. So let's explore that while everything is getting provisioned. So on your AKS dashboard, you would find this new section called Kubernetes resources. It contains 3 tabs underneath that. The first one is the namespaces one. Here, if I refresh, you can see that my application namespace has been created. If I go further and inspect it, doesn't have much information, but you can see that my custom label is displayed over here. If I go back, if I go to my workloads, and filter it by my namespace, you can see my movies API v1 and v2 have been deployed. I can even dig deep into it and see that 2 containers are running. One is the proxy container, another one is the actual workload container. So in the last video, we saw that we could execute a command to actually find out the Istio ingress gateway external API endpoint. Much easier way to do this is through the UI. So you go to the services and ingress endpoint. Then there it is, the external IP. You can just click this IP. You can see that it's now reaching version 1 of the service, because our rule says that if no header is specified, if no version header is specified in the request, by default the request should be routed to v1. So how will we reach v2? So let's do that now. So if you remember that in our specification, we wrote that if the header contains the text version, a header key version, and the value is 2, should reach v2. So you can see here that on my browser, you can see that the request is getting responded to by v1 of the API, whereas with curl statement, the v2 of the API is responding here. So so this is versioning in action with a small bite-sized demo. It is covered in the workshop exercise number 4 as well. And now with versioning, you can realize certain patterns like Canary releases. So how you would realize Canary is by, let's say if you were to have this application deployed in production, then for a certain set of your customers, you can set the version header in their requests, and they would be routed to a new version of your service altogether. In this case, version 2. You can also realize A/B deployments with the versioning feature or the versioning API. You can use the same trick as in use, let's say, the headers in order to route requests to either version A or version B of your service. So now that we have seen versioning in action, let's move on to the next pattern.
Well, there's a nice example. If you open your browser there and open .net, just the .net website, and if you scroll to the bottom, you scroll that to the last thing. You see that there is powered by .NET 5 here, preview at the bottom.
Yeah.
And if you keep refreshing the browser, you're going to see that's going to change to version 3.1. That means that this website at the moment is running 2 different versions.
Yeah.
And that's exactly what you just showed. That's a Canary deployment.
Yes, exactly.
Yeah.
A live example of that going on right now.
That's correct. Yeah, that's the way that we test .NET 5, and we're using exactly that.
Awesome. Thanks for sharing that. New to me. So now that we saw versioning live in 2 scenarios, one on my AKS cluster and one on .NET website, let's realize the next pattern, which is fault injection. So for that, what we are going to do is let's first inspect the specifications for fault injection. So for fault injection, what we are going to do is, again, the same movies API. There is an endpoint in movies API that you can configure in order to return false for some time. So if an API is dependent on movies API, for example, our UI is dependent on movies API for surfacing the movies, you can test the UI by simulating false on the movies API for some time. So how would you do that? So here, again, this spec contains 3 definitions. One is the gateway, nothing fancy here. It's the same gateway specifications that we have used till now. The virtual service specification, if you see, again, there are again header-based routing rules written over here. But one interesting thing you would see here is that version 1 of this API also contains this fault specification. And what it contains is that for successful requests, it would wait for 5 seconds before actually responding to the request. And it would return success in 40% of the cases. For 60% of the cases, it would return the result 500. Which means that whenever you try to send requests to version 1 of the API, in 40% of the cases it would succeed and 60% it won't. And even when it succeeds, it would take 5 seconds before responding. So you can even test how your services would behave if the dependent services are responding very slowly. So the destination rule, I haven't changed anything here. It request to version 1 or version 2 of the movies API based on the subset that is getting requested. So in order to test this, I will first have to apply this spec. So I will move a level up in the directory and change to fault injection. Then I just need to apply this spec, which I will just copy it here. So you can see that gateway has not changed because we haven't made any changes there, whereas the API service has been configured to add those new fault injection rules. Destination rule is still unchanged. So once this is set up, let's execute some curl requests. The command panel for us to test it. If I send a request here, it takes a little bit of time in order to get applied. So here we can see that it has responded with status code 500. When I executed the request this time, if I execute it again 500. This time it took some time, but responded with the result 200. So you can run this in a loop and test it yourself. That is how I have implemented it in the Katacoda scenario. I'm just showing it to you here. Now note that these values, the percentages that you specify, they get averaged over time. So don't expect if you send 10 requests that 6 of them would fail and 4 of them would succeed. It might vary. If you send a large number of requests, they would approximately hit those splits. So that was fault injection in a nutshell. Let's move on to the Canary deployments. Let's study the specs again in a little bit of detail. So,
Rahul, just a question. On the Katacoda, they're going to do exactly the same steps that you're doing there.
Exactly. Correct? So these are the same steps, the same scripts that are available on Katacoda as well.
I don't think we have show anything on Katacoda. If you could just go just for one screen and show how that works on Katacoda, maybe at the end it would be nice.
All right. It takes a little bit of time to load, so I will.
Okay, that's okay.
I will launch it. By the end, it should be up and running.
Yes, I actually are doing exactly the same thing, but using Azure.
Yeah, here we are using Azure. We are now going to talk about how you can achieve Canary deployments with Istio. So let's go through the specs that are available in the Canary folder. If you have downloaded the source code, they are present in Scenario 4 Canary folder. Here you can see there is a gateway spec, nothing fancy here, still the same what we used before. Even here, the destination, the virtual service that we have specified, you would notice that there is a new element present here in the destination object, which is wait. So what we have specified here is that for 90% of the traffic would reach subset 2, and 10% of the traffic would reach subset 1. What we have also done is remove the requirement of having a header specified in the request. So there will be no header-based routing now. It will all be dependent on the wait. So 90% of the traffic reaching your new version of the service, 10% to the old one. The destination rule hasn't changed. It is still going to bridge the gap between virtual service and the actual service by adding this version, adding a further check on the version label. So in order to apply this spec, I need to climb a level up and move to the folder. Just being extra careful here, taking the command from my notepad. You can see that the gateway spec and the destination rule spec have remained unchanged. The service has undergone a change because earlier it was configured to return errors. Now it is just going to do wait-based routing. So to test it, easiest thing would be to just go to your load balancer endpoint and see. So V2, again, V2 is responding to our request. V1 is now responding to our request. Now V2. So most of the time, V2 would be the one receiving our request. And for 10% of the time, you would find V1 returning response. I realize that the font is a little bit smaller, so I will expand, just zoom in. But keep checking this particular text. So V1 is actually rare, but you'll see that it will often change to V1 near about 10% of the time.
Yeah, Rahul, there is any Istio dashboard where they can make those changes, or they always have to change on the YAML file? And
so you can program Istio through YAML specifications. They look pretty much like Kubernetes specifications. So as I said earlier, when we were talking about Istio and the first video, Kubernetes just enhances your Istio just enhances your Kubernetes APIs. So these are some new APIs that it adds. So there is no dashboard most of the time you would not even use the Istio CTL CLI because most of the commands are getting ported to kubectl. So you would most often use kubectl for looking at logs or inspecting all these APIs.
Yeah, true. There are people using not Istio dashboard, but some using some products that kind of integrate with that and make. If you want to have a dashboard, you can have, but not like from Istio.
Yes, that's true. But that brings us to the end of the exercises that we have covered in Katacoda exercise number 4. So if you see the specs that I ran on AKS right now, you would find the exact same specs that you can play with. For example, the movies API service, the exact same thing that I used. Version specs in order to route request to one of the 2 versions of the movies API, same thing. So a fairly safe place to test these features on your own while you're going through this video without setting up a cluster of your own. You also have the bash terminal available here, so you can run any commands. All the script files would be downloaded to your system once you execute the first command. For example, let me do this quickly. So here you will see that all the scripts that I executed in the exact same location are available here. You can modify them and in order to play with them right here in Katacoda. So thank you for watching. I'll see you in the next video.
Thank you, Rahul. Thank you, Fernando. Was
Thanks,
great.
Rahul.
If you want to follow Rahul Ray, our speaker, just go for his blog, thecloudblog.net. There's a lot of blogs here, a lot of content. You can see links for his books. One of the books is the Istio book, just released a few months ago. It's a very nice one. I really like the Kubernetes one as well. Have had a look before. And also, Rahul is one of our bloggers and mentors. There's a few blogs here on azureta.com. Please follow our blog. And Rahul is here as one of our main mentors. Thank you for following and helping. The community is all about helping others to publish content. Thank you.